Here we go. Physics 30S, position time graph, types of velocities. So, three types of velocities that I've already introduced you to. We're going to look at them a little bit more in depth. They are constant velocity, average velocity, and instantaneous velocity. And you just need to sort of follow along with the little booklet there. All right, so constant velocity. You're driving down a highway. You notice it takes equal intervals of time to travel between hydropoles. This is an indication that you are traveling at a constant velocity. The formula for determining constant velocity is v bar equals d over t. And if you haven't yet memorized it, it's certainly time to do that, right? Where v is the velocity, it could be in meters per second, it could be in kilometers per hour. D is the displacement, it could be in meters or kilometers. And t is time intervals, likely seconds or hours. Note that since displacement is either a positive or negative value, velocity will have the same directional notation. Okay, so if the displacement is negative, the velocity that goes with that will also be negative. The similarity in sign for both velocity and displacement occurs because the time interval is always positive, and time isn't necessarily a vector, it's in fact a scalar, it doesn't have a direction, does it? Okay, so a little bit of practice here. Note that when writing the direction of a measurement, we can use the actual direction. It's in the math formula that we may not need to substitute. And I often get students that are a little bit confused, a little bit hung up on when do I use the negative sign, and I answer when you need to, which never really goes over too well because they don't like that answer. Well, that's my answer. So what is the constant velocity of an airplane that flies 602 meters east in 2.5 seconds? Express your answer in meters per second and kilometers per hour. Let's do the first one together, shall we? Okay, so we're going to start by writing our formula. So you should do the same. V bar equals d over t. Okay, and as I said, and I posted up, no, I haven't posted it up yet, so minute rules for test writing, write your formula. Okay, and then it's just going to be v bar is equal to, now you substitute, so that's going to be 602 over 2.5 seconds, and then here's your answer. And oddly enough, I haven't got that number committed to memory. I should have it because I taught it enough times, yeah. Would you believe 240.8 meters per second? Yeah. 240.8 meters per second. When you put it that way, that seems kind of fast, doesn't it? 240.8 meters per second. And it also says that we want to put this in kilometers per hour, so I'm going to write 240.8, and I'm going to multiply by 3.6, because that's the magic number, and I get 886.9 kilometers per hour. So that's pretty straightforward, is it not? Like, really? You did this sort of thing in grade 10. It might have been a little bit more round numbers, like maybe 603, right? But other than that, it's really exactly the same kind of thing. So I'm going to ask, go ahead and do number 2. Actually, maybe, should I do number 2 with you?
No, let's try.
You know what? I'm going to do number 2 with you simply for the only reason that there is scientific notation in there. So let's have a look at that, because I do need to make sure that you can handle scientific notation. Okay, the tine on a tuning fork. When you had your pumpkin pie at lunch today, and you used a fork, the little pokey things are actually called tines. That's what they're called. So there's your vocabulary word of the day. Tine on a tuning fork. Whether it's a tuning fork or a pumpkin pie fork, it's still called a tine. It moves 1 millimeter to the right in 4.0 times 10 to the minus 3 seconds. What is the constant velocity of the tine in meters per second? Now, it actually wouldn't be a constant velocity. In fact, it would be an average because it would have to speed up and slow down. But semantics aside here. I want to know it in meters per second. So there's a couple things I have to show you here. First of all, I have to remind you how to go from millimeters to meters. So if I have one millimeter, is that going to be more than 1 meter or less than 1 meter? Quite a bit less than 1 meter, right? It's teeny tiny. So am I going to multiply by 1,000 or am I going to divide by 1,000? I'm going to divide. So 1 millimeter, right? I'm going to divide that by 1,000 and I'm going to get 0.001 meters. So just a reminder of how to do some of that kind of stuff. Now, what is the constant velocity of the tine? V bar is equal to d over t. The displacement is 0.001, and my time is 4 times 10 to the minus 3. Now, on your graphing calculator, you should have a button that either says EE or EXP. Let's learn how to use them. Please do not go multiply times 10 and do that way, okay? Because it will get you into trouble sometimes. Okay, so find an EE or an EXP button. Quite often the EE is a second function one, and the EXP is just a plain old button one. Okay? You may need an actual scientific calculator. I don't know if the iPod or iPhone calculator actually has that. Okay, so now what you're going to do is you're actually going to go 0.001 divide by, and then 4 EXP minus 3. And I'm just going to show you that on my calculator up here. While that's loading, I can tell you that the answer should be
0.004 meters per second.
Okay, here I got my calculator up here now. With your calculator, you would go, it would be 0.001, and then you'd go divide by, and it's 4 times 10 to the minus 3, right? So it's 4. Now when you go times 10 to the minus, the times 10 to the minus is the EXP. Okay, you don't go times 10. You just go 4. Mine is an EE button. Can you see it? Just barely make it out on the side of the calculator. So I'm going to go second function EE, and it puts a little E up there. I don't know what it does in your calculator. But when you go EXP, it does the times 10 for you. So all I have to go do is go 4, E, and then minus 3. And you should get an answer of 0.25.
No.
0.25 meters per second. And I'm just going to pause there, and I'm going to let you try it on your calculator. I'm going to come around and see if you can do it.
So what is that?
The question, what does the minus 3 mean here? Well, 4 times 10 to the minus 3. Like if you actually went on your calculator, it means 4 times, what's 10 to the power minus 3? It actually means, no, well, do you guys know what a negative exponent means?
Nope. No.
Yeah.
I forget.
You forget?
I forget.
Like,
Never learned it.
10 to the 3 means 10 times 10 times 10, right? 10 to the minus 3 means 1 over 10 times 10 times 10. The minus just means put it on the bottom. So when I go 4 times 10 to the minus 3, it means 4 times 1 over 10 times 10 times 10, which is 4 over 1,000, which is 0.004, which if you move the decimal places, 1, 2, 3. That's really kind of what it means. Okay, so my answer is 0.25. All right, I think there's 3 more questions left. Am I right? Okay, so you guys, the number 3 has a scientific notation on it. So go ahead and do number 3, 4, and 5. I'll give you about 3-4 minutes while I do attendance, and then I'll check them with you.
Okay, I got that one right. Meters per second. Meters 3.6. Yeah. Oh, I was supposed to.
Say it aloud, Jason.
I'm not going to say it out loud.
Jason, you can't be.
I'm talking in general.
Yeah, but I can hear you.
Okay, well, let's get out my handy-dandy little graphing calculator here. So, are we all agreed that, are we all kind of good? Can I do this?
Nope.
Are we all good, like, for the formula manipulation? It's just the actual arithmetic that's hard?
Yeah.
Everybody's good with the setup?
Yeah.
Yeah? So it's just how do I do it, right? So it'll be 1 divided by 1.3 exponent times 10 to the minus. You don't have to go times 10. Do not do that on your calculator. And then it's 5. Okay, my calculator puts it in automatic scientific notation. If yours doesn't, I can show you how. I am a math wizard, a calculator genius. The answer is 7.69 times 10 to the minus 6. You should have on your calculator, you likely have something, if you are lucky enough to have an FSE button.
I don't have one of
If
those.
you have an FSE button, you are in luck, because the FSE stands for fixed scientific, and the E stands for engineering.
I have an FLO button.
Okay? No, you don't want the FLO button.
No, I'm
Hello?
FSE. Very few, most calculators don't have it anymore. Okay, but if you have it, then you're in luck. No. You might have an
I
SCI.
have an HIT.
If you have an SCI, then you want to put it into SCI mode.
Scientific notation or decimals accepted.
Well, again, if it's more than 2 or 3 zeros, like if your calculator shows 0.000000769, I kind of want that, like, don't make me count. I got 27 kids to count, zeros,
Well, I don't.
right? So, I mean, that's what you would get, and then you'd have to go what it would be. It would be like 1, 2, 3, 4, 5, 6. 7.69 times 10 to the minus 6. Excellent question. The traditional scientific notation is 1 before the decimal, always 1 before. Like you'll never see, this could also be 76.9 times 10 to the minus 7, but it's almost, I go after. I've seen 1 in front and 2 behind, as a general rule. Don't get hung up on that. I'm not going to worry about it.
Well, then, that's how we know to.
Let's have a look at number 4. Are we ready to see number 4?
Yep.
Yeah? Okay, now this one here, because you've got days and kilometers per hour, you're going to have to do some unit conversion. Anybody want to do dimensional analysis? Anybody lucky enough to know what that means?
Nope.
No? Okay, then we won't do it. Never mind.
What is the name of that question?
No, dimensional analysis.
Oh.
That's where you take the units and do lots of crazy canceling, and yeah, textbooks like to do it.
That's funny.
Okay, so let's just take, now, should I take my 3.2
No,
times
just
10 to the 4 kilometers per hour, and should I turn that into kilometers per day? Or would it be easier to convert 2.7 days into kilometers?
How can days be converted?
Concussion. 2.7 days into hours, thank you, right? Hours. Everyone's looking at me. 2.7 days times 24, right? Somebody help me out there. 64.8 hours. That's an 8. Okay, so now I'm looking for the displacement. V bar equals d over t. My velocity is 3.2 times 10 to the 4. My displacement is my d. My time is my 64.8. Please notice how I wrote the formula, substituted numbers, and now I'm going to actually solve. There might be some of you that want me to write 64.8 times 3.2 times 10 to the 4. If you think you need that, then you go ahead. If you think you can skip that step, you can do so. I get 2.07 times 10 to the 6 kilometers. Anybody else get that?
I'm not there yet.
Okay, try it on your calculator. I'll pause and wait for a second. You might not get the 2.07. How many people know that the 64.8 is not exact? Like, here's what I actually did, because I know all the little calculator tricks, right? I don't need to do this. I can just write, and this is exactly what I did, and I screw this up every year. I've actually got 2.7 times 24 equals d over, no. Back up. Blue. The velocity is 3.2 times 10 to the 4. And then I put a d, and then I put my time down here, and I put my 2.7 times 24. And I just, when I did it like that. I did this step all at once down here. And so when I did it on my calculator, watch here, Dana, because I'm sure this is what happened to you here. So what I actually did was I went 3.2, right? 3.2 exponent 4. Second function e. Oh no.
Column.
Back up. Second function e 4 times, and then I got to go 2.7 times 24, right? Do I need the brackets?
Yes.
No.
Why not, Ryan? Because the order doesn't matter when you multiply, right? Like a 1 times 2 times 3 is the same as 3 times 2 times 1, right? So I mean, you can put them in if you want, but it's not going to make any difference. 2.7 times 24. So this is actually what I did on my calculator, right? And this is how I get the 2.07. Okay? Because we did this, the 2.7 times 24, and then we did a bit of rounding, we lost some precision here, right? So it's probably a good idea to do this. Here's a great example of where if you gave me an answer of
I got the exact same.
2 times 10 to the 6, but I got on my paper 2.07 times 10 to the 6, as long as I see how you arrived at that, full marks, no problem.
Yeah, but what did you do with the 3 and the 6?
What did I do with the 3 and the 6?
Because you kind of like put the. You got rid of the 3 and the 6.
And even when they cut it off, we have more numbers after the 2.07.
I would just go 2 after is 20.
Okay.
Well, like, what happens?
So you just forget about those other
Well,
numbers?
it's not relevant because like 2.07 times 10 to the 6. Let's talk about this for a bit, right? So 207. So what are your numbers?
3600.
3600. Okay, so in the big scheme of things, we're talking about 2,073,600, right?
Yep.
So how much percent difference is there between 2,073,600 and 2,070,000?
Well, then.
Like it's not significant enough. Oh, well,
But doesn't matter.
You just leave it the way it is?
sure. I mean, I rounded off this 7. If this 3 was a 6, then I would have rounded it up to 2.08. When you round off, do you go all the way and work your way down, or do you just go to the one beside it? Just the one beside it. You know what, you guys? This happens all the time. I know you guys are all relaxed. Deep breaths. Right? I will accept multiple answers on a test. Okay? I don't care about the answer. I care about the process here. Show me the process. I'll follow it through and I'll figure it out. Oh yeah.
You'll just accept
But,
it. You'll write
you know-
the answer, right?
But she doesn't want
But what if it's times 10 to the 19? You're going to write out all those zeros? No, I'm not going to count it. I will. If it's more than 3 or 4, put it in scientific notation.
Okay.
You're big boys and girls. Put it in scientific notation. You can do it. Yes. Let's go to number 5. A motorbike is traveling at 85 kilometers an hour as shown on the speedometer. How many seconds will it take to cover a 200-meter track at this constant rate? Now I made it a little bit hard. What's hard about this question? There's converting, exactly. It's 85 kilometers per hour, but the track is in meters, and it asks for the other thing in the time in seconds. I got to do some converting. What's easier, converting 85 kilometers an hour to meters per second,
Yeah.
or 200 meters to kilometers? Well, they're probably both the same, but I also need my answer in seconds, right? So I really should take my 85. And how do I go from kilometers per hour to meters per second?
Divide by
Divide. Show that step.
23.6.
23.6 meters per second. Round what up?
I had 23.61 reading.
That's fine. 23.6 is good. It's close enough. It's a process. Now I'm going to write V bar is equal to D over T. 23.6 is equal to distance 200 over time. Remember, these are the math things you've got to be able to solve in your sleep almost. T equals 200 divided by 23.6.
How many decimal points?
Stop worrying about it. There's one decimal place here. I would go one more. That would be my instinct. I get 8.5 seconds.
Okay.
Again, if you got 8.49, as long as I see, hey, they know how to divide by 3.6, they know how to substitute this. Like, I mean, if you got 8.51 and I got 8.5, I'm going to take it. I have 8.5 and you have 17.3, we got a problem. Right? You're not going to have a number that's so close that you think it's right, but I think it's wrong, and we're going to have an argument. It's not going to happen. Okay? You're either going to be really, really close, and I'll say, yeah, that's good enough, or you're going to be really, really wrong, and you're going to say, yeah, I realize that's wrong. It's not going to happen. All right, so average velocity. This is the second kind of velocity. Average velocity of V-bar. Average velocity can be determined two ways. First one is by formula, right? And that formula is, now is it here? I just have to, yeah, it's not there. V-bar equals d over t, where v is the velocity and d is the displacement, t is time, right? So that's one way to find average velocity. This formula will be used when you're asked to determine average velocity in a word problem, okay? And it's not at a constant speed. For example, a bike travels 3.2 kilometers in 45 minutes. Does the bike travel at the same speed the entire time?
No.
No.
We don't know.
Well, we don't know, but it's not likely, right? It's not likely. So, what is its average velocity? In other words, these are exactly the same as what we did before, except we assumed the ones before were all at constant speed. Now you're talking like a longer period of time, and it might be changing time. So the average velocity here is going to be... Now I do have a little issue here. What's my issue?
Kilometers.
I got kilometers and I got minutes, and they don't usually like to mix together. So I should probably turn my 45 minutes into hours, right? And that, of course, would be 0.45, right?
No.
Okay, good. It's not that. You'd be surprised how many people want to do that. 45 minutes, oh, that's 0.45. Yeah, most people know that. 45 minutes, 0.75. You just sort of know that, right? What if it wasn't 45 minutes, Hannah? What if it was...
35.
Nope, I meant to write 41 minutes. What if it's 41 minutes, Hannah? What are we going to do? How did we turn 45 minutes into 0.75? Oh, you don't know.
Divided by 6. Yeah.
Divided by 60. Thank you, Ryan. Divided by 60. So if it's 41 minutes, then it's going to be 41 divided by 60. Whatever that means. 0.68?
0.68.
All right, but it's not. It's 45 minutes, so we know it's 0.75. So I'm going to have 3.2 divided by 0.75. And what do you guys get? I get 4.4. I get 4.3. 2.26. 4.3 kilometers per hour. All right, easy enough. Yeah, it's not particularly. All right, that's an easy one. What about this one? A vehicle travels 30 kilometers east in 15 minutes, 40 kilometers west in 20 minutes, and then 10 kilometers east in 7.5 minutes. What is its average velocity? Hands up if you now think, oh, this is going to be hard. Go ahead, be brave. Okay, apparently everyone thinks it's going to be easy. You're wrong, it's going to be hard. Okay, so, first of all, we're asked for velocity, so that means we're talking about distance or displacement?
Displacement.
Displacement. So what is my dt? Displacement total. What is my total displacement? 30 kilometers east,
Negative 15.
45 west is going to be...
15.
Now, would you like me to write plus a minus 45, or do you want me just to write minus 45? Does it matter? I like them plus minus 45. Seeing as I'm writing it, I get to do what I want. And then 10 kilometers east. So plus 10. So what is my total displacement? 30. Do you want to go minus 45 first, or do you want to go 30 plus 10?
It's minus.
I would do 30 plus 10 in my head. 30 plus 10 is 40, minus 45, minus 5 kilometers.
How long did it take?
Minus 5 kilometers. What is the time? Oh, now I really need I'm going to do something kind of funny here. I'm going to write a small t because that's what I like for time, and then I'm going to put a big T for a subscript for total. So total time,
42.5 minutes.
15, 20, 7.5, and what'd you get, Steve?
42.5.
42.5, I think that sounds familiar.
Then you gotta convert it.
42.5 minutes. Oh, here we are again in another problem, right? What is it? Well, we've got kilometers, we got minus 5, that's not a point, that's minus 5. We got minus 5 kilometers and we got 42.5 minutes. One of them is going to have to go to either meters or hours. The question doesn't say what the answer has to be in, does it? Doesn't say meters per second, doesn't say kilometers an hour. So of these two, which would you like to convert? You want to convert 5 kilometers to meters or 42.5 minutes to hours?
It doesn't work when you convert meters and hours.
Oh.
You're right.
Do you have to divide it by 60 and then multiply by 3.6?
No. But you're almost right. Let's convert the 42.5 to hours. That seems to be what everybody wants to do.
Yeah.
So it's going to be 42.5 divided by 60. And I don't know if I have that. Oh, I do. 0.71 hours. Is that what you got?
Yeah.
Okay, that's 0.71 hours. And now my velocity is distance over time. Distance of technically it's minus 5. 0.71 minus 5 divided by 0.71 is, I get minus 7. There must be some rounding there.
So you want 0 to be 5.
Minus 7 kilometers per hour. So Peyton, you don't do any multiplying by 3.6. You only use that when there's meters per second and kilometers per hour involved, right? We converted 42.5 minutes to hours, right? Because we want, our speed has to be kilometers per hour or meters per second. So I can't have kilometers per minute. You can, it's just not common to it. Yeah. It's not sort of accepted.
Well, it should be accepted.
Oh, well, it's not.
Right.
It's not socially acceptable. It's kind of like, typing in all caps. It's just not. It's kind of rude.
Hey, caps lock is cruise control for cool.
You're angry. Angry, very
You know how long it took me to figure out how to do caps lock on an iPad? Yeah, I know now.
Actually, I still don't know how.
I know now.
You know how much I regret having my passwords all in uppercase now?
Hey, caps.
I shouldn't have said that, should I? You've got a 1 in 26 chance of guessing one of the letters. Okay, number 3. Now this one is the grandpapa burger of all of the A&W family of physics questions. Okay, last question of the day, likely. An orienteering athlete. Those are people that go out and do cross-country running, but they cross-country run with a compass, and you have to find their way as they run. So it's both athletic ability as well as intellectual. Who might that might be good at something like that? Liam?
Yeah.
Well, I was thinking myself, but yeah, probably
Except Liam doesn't know these too much.
We'll put an L on his arm for a W, not a left. Not a left and a right. Okay, orienteering athlete walks 1.2 kilometers east in 25 minutes, then 0.8 kilometers north in 50 minutes. Determine her average velocity. I hope you're working in pencil.
Oh, man. I don't know how you can do these things.
Am I on the right track here?
Sure.
The answer to that is no!
I already know that.
Which is what I said, I hope you're working in pencil. One surefire way of making sure you don't make a mistake like this is to force you to make this mistake and then erase it. What's wrong with that?
Well, they're two different directions.
They're two different directions. Exactly. You can't just add the numbers together. That is wrong. They are vectors. Yay! Bringing back vectors. No, it goes like this. Yay! Bringing back vectors.
Yay! Bringing back
There you go.
vectors.
You mispronounced it.
No.
1.2 kilometers east.
East.
1.2 east, and then 0.8 north. Oh, I should do this. 1.2 east, and then 0.8, and then this would be my resultant, right? Oh yeah, now I remember doing this. Can I now just go 1.2 plus 0.8?
No.
No.
Gotta go a squared.
You mispronounced it, Steve. It goes like, wow, I love vectors. 1.2 squared plus 0.8 squared. Yeah, but without vectors, you wouldn't get that little gag from Despicable Me movie.
I never did
Never even
understand
seen
it.
the movie.
No? What?
You showed it to us before I knew what vectors is.
Oh, really? You didn't get it? Do I need to show you again?
Yes, right now.
You're just saying that.
No, I
1.2
actually don't
squared.
understand it.
I really don't get it.
Yeah. Because
1.2 squared plus 0.8 squared is equal to 2.08. Take the square root of that. I get 1.442. 1.442. Now, does the direction matter?
Yes.
Here's my Bennett's general rule that says if east or north or south or any direction is given in the question, it's likely going to be in the answer. So you do need to find the angle. Inverse tan, opposite over adjacent, 0.8 over 1.2. Sure wish I could make that go away. Here I go. Second function tan, 0.8 divided by 1.2. What angle do you think it's going to be roughly?
not sure.
33.
Oh, that's not what I got.
0.58 is the angle? Does that make any sense at all? Is your gut telling you that something's wrong? Yes, and I know exactly what it is. Maybe you don't, but at least you know something's wrong. Something that's wrong is that I am in radians. I must be in degrees. Yes, I am being a bit of a radical. So I got to recalculate that. 33.7?
Nope.
Let's round that up to 34. 34 degrees.
What's the difference between like radical?
0.8.
If I get time at the end, I'll answer that. Yeah. If you never run across radians, Jake, you're probably out.
How would it be?
What was my answer again? 34?
33 points.
34 degrees. Okay. Now, what else do I have to do? Now, can I go 25 plus 15? Like, do I need to do a r squared equals 25 squared plus 15 squared? Why not? Just time. It's not a vector, exactly. Not a vector. So my total time is my 40 minutes. I got to convert 40 minutes to hours.
I'll just do a second.
You're going to get 0.6 repeating.
Zoom in.
And now I can find my average velocity. V bar equals d over t. I'm just going to leave it as 0.6 repeating because I would like to keep that precision. So my total distance is 1.442. My time is 0.6 repeating. Now, how the heck am I going to do that on my calculator? You can go 0.6666666 if you want, or if you're a super genius, much like myself,
so modest.
you would go 1.442 divided by, now how did I get my 0.6 repeating? Well, I took 40 divided by 60, so I'm going to divide by, I'm just going to write 0.6 repeating like a fraction, which is 40 divided by 60. But it's got to be inside brackets. Right? Because 0.6 repeating and 40 over 60 are the same thing, are they not? So I get 2.163. And that is going to be kilometers per hour. And my angle is going to be east 34 north. East 34.
Okay, how would you tell that it's east? I know it's east and north.
Because the east is the one that you're measuring from the one that's on, I don't want to say straight because that's not true, but one that's either straight across or straight up and down, right? Like this, I already have my east already there. I've got east and then I go north, right? If I had my north in there, then it would be the other angle.
So if you went north first and then east second,
It would be not 34, it would be 56, wouldn't it?
Yeah.
Right?
Can you watch that Despicable Me thing?
Now that you know what a vector is,
Yeah.
you think it's going to be funnier?
Yeah. I never got the joke.
Okay, we will pause there. We will rejoin the movie in progress at part B there tomorrow. I thought we were going to get a little bit farther today, but we didn't. Oh. Well, that's where we're going to carry on tomorrow.